Hello. So, I hope that was a seamless transition. But I'm going to use the substitute command. So what you do is you have an expression. And let's put expression around it. I could have just put an expression in there, but this prevents it from being thought of as an argument. So that is something. Okay. Okay, sine of x plus y plus 2 plus z. That's an expression right there. And then what we do is we have an environment. Now, this is the neat thing. I could go env equals and then put an environment name, where what I will do in the environment is put in, for instance, values for any of these expressions that I want filled in. But you can also just put a list in here. So I'll put a list and I'll put z equals, let's say, 1 to 10. I might regret that. But you know, it doesn't have to be evaluated. So even if the thing I do doesn't make any sense, it'll still work. Watch this. I do that. And look at what happened. Here's the expression right there. Sine of x plus y plus 2 plus, but now z has been replaced with 1 to n. Now whether that can be actually evaluated is a whole different question. That's an expression there. They're probably the wrong lengths. So in fact you can make a, okay, well, it's going to evaluate the substitute command. Okay. So one of the things this is often used for is for creating text. So let's say you import as one of your arguments, I should say, in a function, you have this y equals this expression here, and you want to fill in some parts of it, like that z1 to 10, and then you want to print that out, say as a title. A nice command for that, since that's an expression, is the command dparse, because what that does, it reverses parse, so it takes expressions and converts them to text. There we go. We got an expression there. Okay. Let's look at a similar thing. Let me see. One without expression. There's a, without explicitly saying expression, there's an expression right there. Okay, it'll substitute z, and then it should, the dparse this time is going to be, okay, dparse substitute is going to take the z, replace that in the expression, except it doesn't evaluate it. Okay, so you get this, and then you dparse it, which converts it to a string. If I wanted to evaluate it, oh no, if I evaluate it, it's going to evaluate substitute. Okay. A funny example of this is quote. So quote, well, let's see what quote does. So let's say class X is numeric. Let's do something like mean. Okay, that's going to be a numeric. Mean itself. It's a function. So what does quote do? So quote of X returns what you had there before, but what's its type? Its class, I should say, is a name. So what this does is it converts functions to calls. It converts what would just be an assigned expression, x, that would get evaluated to a name, because it's x itself is a name. So essentially what quote does is it returns what's here exactly as is. So is returned as x, even though x itself has a value. Quote prevents it from being evaluated. So quote kind of stops evaluation. So what do you think if you say eval of quote? So in other words, you evaluate something that's pasted, a bunch of things pasted together, and some of them are quoted things. it turns out eval and quote cancel each other out, because remember, if you just say x, x gets evaluated. So x is 12, because that's what inside the environment, that's what the variable value of x is. So it's substituted in the parse. It's parsed out and evaluated. But if you put quote around it, it kind of blocks that, and you just get x. So eval evaluates the function quote of x, which just yields 12. Okay, so eval and quote are kind of inverses of each other. This is talked about in the book. So if you want to evaluate things, typically eval will actually do the computation. Okay, 12 plus 2, this expression gets evaluated. But if I quote this, it blocks it from being made into an expression and just leaves it as a name or a call, which when it's evaluated, it just comes back as x itself. So evaluating quote just yields x. So they kind of cancel each other. So let me see. What do I want to do other than so you get the idea. Substitute in general replaces parts of expressions. And then depart is a way of converting those into strings if you want to use them as titles and such. Okay, let's do another one. So what do you think this would be? I don't know if I have I'm missing a z, so I'll do substitute a plus z list equals, list of a equals 10. What is going to happen here? Okay, so substitute is going to have the take the expression a plus x. It's going to look over here. This is the stand-in for the environment, so it's going to put a equal 10. So this is going to be 10 plus x. So this whole thing, the substitute is going to be the expression 10 plus x, and then it'll get evaluated, which yields 22 because x is equal to 12. Oh, okay. Yep. Okay, and what's the type of that? I'll bet you that's an expression. Oop. Or in this case, call. Unevaluated expression. Okay. Evaluating substitute. Good. That's going to be enough for that. Sometimes when you want to pull out parts of things, you can do all names or all vars. That's kind of an interesting one. So let's do this with a formula. So if you're presented with a formula, so y equals u squared plus u plus z, all names. Now notice all names has extra arguments. One of them is functions equal true, is the default. So if I just do this, it's not only going to be names, but also functions are going to be pulled out. And there's also an argument unique where the default is false. So if things occur more than once, they're going to show up here. So what this is going to do is essentially tokenize. It's going to show all the tokens inside this. So here you go. There's your tilde. There's your y. You have a plus. You have another plus, you have a power, you have u, u, and z. A little more succinct, well, I could do unique equals false. Oops, true. That had unique equals false. Okay, then it'll only show each of the tokens one time in that formula. A faster way to do that is all vars. What that does, it even leaves out functions and just puts variables. So and just gives unique ones. So here's your variables, or your names in there really, y, u, and v. Okay, so that can sometimes be handy, pull out parts. By the way, formulas are kind of interesting. So here's a formula. If you want to pull up the parts of this, pull it to pieces, you actually can do that with, take the little parts. This part is going to be the tilde, yep. Second part is the left-hand side. Third part is the right-hand side. So if you want to break it into parts, you can do it that way. So if your argument of a function is a formula, you can get pieces.